Welcome to my talk about Eclipse 4, a major upgrade for Eclipse for the Eclipse platform. Short introduction about myself. My name is Tom Schindel. I'm CEO, CTO of a small tech company located in Western Austria, Central Europe. I'm Eclipse committer at various Eclipse projects, starting from E4, which is the project Eclipse 4 got developed in, Platform UI, which is the old FieldX stream, EMF, and other projects at Eclipse. I typically blog about all the stuff I'm doing at Eclipse at my own blog. So let's look a little bit into the history of Eclipse 4 that you see where we are coming from. So at EclipseCon 2008, 4 years ago, the Eclipse 4 project was announced. And by then I was in the audience and listened what they think they should do in the future with Eclipse and thought I would like to be part of it. So I started contributing to the Eclipse 4 project. So I was in the audience like you are now. In May 2008, Boris Bukowski, an IBM employee, and myself published the first prototype to what we thought would be a good idea for the next Eclipse platform. We set out the rules and the stuff that Eclipse 4 is now based on. We published not only the intention, but we also published code so that people could try things out and give feedback immediately. In summer 2009, we've published our first tech preview called E4.9. In 2010, we published Eclipse 4 SDK as a developer preview. And in 2011, we published Eclipse 4.1 SDK together with the Indigo release. And it was the first time that we started self-hosting. So we used Eclipse to develop Eclipse. And as most of you probably know, in 2012, we shipped the new release train on top of Eclipse 4. So if you now download Eclipse Juno, you will get Eclipse 4 plus various plugins. So what have been the reasons that we thought we should create a new platform or rewrite the platform? What was wrong with Eclipse 3.x? Well, we all use it every day as a development environment, so why can't we stay on the same thing and go on forever with it? Well, there have been various reasons. When Eclipse 3.x got created, there have been only a few customers. In fact, the only customers we had was GDT, PDE, the Java development tooling, the plugin development tooling. But when we reached the space of RCP, our customer base grew into the thousands, and we had a lot of requests from people around the world. We need this feature, we need that feature, and the old platform was not prepared for that. The other thing that we saw is that Eclipse 3.x uses a very old programming pattern. You have statics and singletons all over. We have a lot of inheritance going on in the platform. We have outdated pattern like the listener pattern, and even worse, we have an inconsistent one. So we have listeners where we pass around event objects, we have listeners where we pass on strings, and the problem with our listeners is that we have ePart listener 2, 3, 4, 6, so the listener pattern really has its disadvantages. And the second thing I already mentioned is that we owned all the world's problems. Whenever you wanted to have a feature, it had to be the platform team implementing it for you instead of giving you the possibility to implement it on your own. So what have been the targets of even the first prototype already set out those targets? We wanted to have the UI components being completely decoupled from the Eclipse framework, so that they have been simply pochos, and you plug them into an Eclipse platform as the UI. So we wanted to remove all reach outs to statics and singletons. We wanted to remove the old listener approach and switch over to a publish and subscribe event bus system. And one of the major first things that I was very keen on was that we should not depend on SWT to render the UI. So I want to have a framework where I could exchange the UI technology without losing all the features you get from a modern platform. The first approach I did, I used Qt for that. So I replaced SWT with Qt. And we approached this thing using an HTML-like DOM in the background. So Eclipse 4 has in the background something like a browser DOM, and we only interact with this browser DOM, and what you see in the UI is only a reflection of the internal state of our DOM in the end. I will show you in examples how this is working and how cool this is. So to approach all this, we created a platform called the Eclipse 4 application platform. This platform consists of the GRE, OSGI, and EMF. EMF is the Eclipse modeling framework. We used EMF to get a statically typed DOM in the background. The Eclipse 4 application platform itself has a so-called workbench model. That's the DOM in the background. We have written our own dependency injection container to do dependency injection. This was the replacement for reaching out to statics and all the stuff. And we have a very thin service layer which provides you the services to interact with the DOM and the platform itself. And on the other side, well, it's not part of the core platform, is the rendering and the UI. So all the blue parts don't depend on SWT at all. So you can use them with any UI technology you want to, even HTML. So they really don't depend on SWT. So when we look at how the Eclipse SDK is structured, when you look at FieldX, there are two projects called PDE and GDT, the plugin development environment and the Java development tooling. That's the thing you normally use as a normal Java developer. Probably you mix in the web development platform, WTP, but that's it in the end. The thing that we are working on is the platform layer. It provides all the plugins and all the stuff that you can arrange views and parts and editors and takes care of them. When you detach them, when you move them around, that's part of platform UI. That's the area I'm working in. And at the low level, we have Equinox as our OSGI container. When we compare that with FieldX, in the end, PDE, GDT, and Equinox are completely the same. No line in there has changed. So it's completely the same code base. What we did is that we created a platform fork, FieldX, and in between Equinox and the platform, we put our new Eclipse 4 application platform. You can call it RCP 2.0. When we take a closer look, even at the platform level, 95% of the bundles or the OSGI plugins didn't change at all. It's only one bundle that we have re-implemented in FieldX. It's UI.workbench, which has a FieldX branch and a FieldX branch. And normally what all those plugins in Eclipse do, they program against the API of UI workbench. So the view part, the editor part, all of them are part of E4 UI workbench, and the API in there hasn't changed at all. So if you have used only public APIs of Eclipse, everything you wrote for FieldX will work the same on FieldX. The magic happens in the UI workbench, where we translate calls you make to the API to the new representation in our Eclipse 4 application platform. One word about performance. Well, when we released Eclipse 4.2, we suddenly had 100,000 of users or thousands of users. And we got a lot of performance reports that in the combination of plugin X and plugin Y, we have a problem. So we're working on it, we really work on it, and we really take care that with Kepler you get everything working, performance, and everything better than probably in FieldX. But we're really keen on working it and doing a hard job. We really take care of that. So let's take a short look at the new programming model that we emphasize. I said we don't want to reach out to statics and anymore or doing inheritance. So when we look at the past in FieldX, this is how you structure a part in Eclipse 4. You derive from a base class called viewPart, and then you reach out to informations like getSite, getWorkbenchWindow, and get the selection service. They register a listener. And this approach has various problems. Well, we depend on the framework, so we can't easily unit test this part because we have to bring up the complete framework to get access to getSite, getWorkbenchWindow, and getSelectionService. And we derive from that, so we can't compile it without having Eclipse with us. The approach we take with Eclipse 4.x is that we make your part a simple pocho. So remove the deriving from a base class, we remove breaking out to get services, and instead of that, replace that with dependency injection. So we simply annotate methods, and because of those informations, the framework can fill out and inject informations you require to get the UI up and working. And if you look at this class, you can easily unit test this class without getting the framework up and running. Because you don't reach out to other services and statics, you get all of them injected into your component. A nice little feature is when you look at how you get access to preferences, for example, it's the same. To make this thing unit testable, you need to get up an OSGI framework, simply to get access to preferences. In Eclipse 4, all you have to do is you annotate your method, you annotate, you add preference annotation in there, and the framework figures out everything for you. So whenever the preference is changing, you get a re-injected value for your pocho. I said we had problems with the listeners and the event system. So this is how it looked like when you get access to your custom service and want to register a listener in FieldX. In comparison to 4.x, all you do, you say inject, and then you add an annotation at event object, and you have an event bus. So when an event is delivered or published on the event bus, you get the value injected. Once more, it sounds like magic, but in the end, it's really cool because all your components don't depend on having a framework running. You can simply call a method on your own. The event object is a little bit dangerous because when you work in UIs, you always have to sync back to the UI thread. So an event system is able to send out events on various threads. So what we added there is we can annotate it with UI event object, and then the framework takes care to sync back when it calls the method to the UI thread for you. So what could be the future? That's the present. That's what there already in Eclipse 4.2. In future, what we could allow you is that you create your UI using JavaScript. The framework itself doesn't care whether something is implemented in Java, JavaScript, Groovy, whatever, you name it in the end. It's only the dependency injection container that must know how to create an instance of what you present to him. So in future, it would be possible if you want to write your UI or your parts in Eclipse 4 using JavaScript, for example. So a very cool thing about Eclipse 4, and that's what I have been responsible for, is the so-called application of workbench model. In the past, I'd call it the Blackhole Eclipse, because when you configure Eclipse and it gets up, you have a Java model where you create the so-called workbench advisor, an action bar advisor, which was responsible for creating the toolbar and the menu bar and all this stuff. On the other hand, you had those plugin.xml files where you did all the contributions using extension points to Eclipse. And when the framework starts up, it reads all those information and plugs them in, and out of that, at runtime, the Java model is completely gone. You don't have access to it anymore. You can't access it. out of that what gets created is so-called descriptors. So we have descriptors for view parts, for editor parts, but all of those informations are read-only. You can only read them, but you can't write to them. You can't change informations in there. So it's a fixed model. When the framework starts up, it takes all those informations, merges them, and then presents you read-only informations. The present now is that in Eclipse 4 we have a so-called application model. And when you look at this screenshot, you see exactly that's the application model of a simple Eclipse 4 application. It is made out of a trimmed window, a main menu. It has a perspective stack, and it splits its perspective through using a sesh container and puts there some tabs. But that's in the end, at design time, you use the same model that we're using at runtime to render the UI and show you the UI from Eclipse. And when you want to interact with this model, you simply get access to it. We have some services so they can access the part stack, for example, is the thing that makes tabs. And when you want to remove an element from this tab, then you simply call getChildren.remove. Similar to what you would do in a DOM in an HTML or in a browser in the end. So you get access to the background information about the UI and operate only on this DOM information. The same is true if you want to change a label at runtime. You simply call setLabel on the element and the label is updated. I will show in a demo. Yeah?
It looks like you should do something that now requires casting.
Where?
It looks like you have casting and part stack and part.
Yeah, because mfind can find any element in the system in the end, right? So we have another method where you say which type you want to search for, but the generic one simply gives back a so-called MUI element and you have to do a cast. Yeah. So you might think, what is all this stuff good for? It's for the plugin developers. Do I profit from it? So the answer I can give you to that is that what you see here are 3 bug numbers at Eclipse. And this bug number asks for a very special feature. The feature is quite an easy one. When you close the last element in a tab folder, the tab folder should not collapse. So when I now click on a tab folder, it collapses. And the feature asks exactly for that. If I click on that, the tab folder should be there and still occupy the space. Interesting enough is that implementing this feature in 3.x is very hard. Let's do a comparison. The first 2 bug numbers are, well, in the first one we tried to implement the feature and got halfway. Nobody recognized that it's not really working, so it got into the code base. And then the second bug got found a lot later that it is not really working, and we tried to fix it. When we look at the fix for the first 2 bugs, we had to touch 7 classes. For the fix in 4.x, we had to touch 2 classes. When we look at the lines of code, we had to change. It's 130 in 3.x and 5 lines in 4.x. I don't know how long it took to implement the first bug or to introduce the feature which is not working, but I have tried to fix the problem and it took me 3 to 4 days to fix it. And then I thought I fixed it, tested it, and it failed once more. And we found out we are unable to fix it in 3.x. In 4.x it took me 5 minutes. The reason is, when you look at the code I had to change, it's really only 5 lines of code that I had to change. So what you profit from this is that we are much faster fixing bugs in our system. Because we have to touch much less classes, we are much faster in fixing and finding problems in our code base. because of the new programming model. I really split out things very good. So now it's time to do some demonstrations, which uses the live model. So when you look at our running Eclipse, we can open a view that's called live application model. So it opens up down here. This model that we see down here, that's the live model of our running Eclipse instance. So I can interact with this model. Let's try it out. Let's flip. Oh, that's the wrong sash. Let's flip another one. This one. When I interact with the live model, you see I change the UI model, and immediately the UI gets updated. So I really interact with my application. I can do even crazier things with it. I can, for example, switch between perspectives. Let's look at the perspective stack and switch over to the Git repository exploring. Now the Git repository exploring is showing. So we can interact with the model at runtime using this live application model editor. And it really helps you to debug your UI when you have problems, when you don't know what things are going on. You even can go here and see which control is rendered in the UI. So it shows you, oh, it's this sash container. Or when we look here, you can see, okay, that's that stack on the left-hand side in the end, right? So we have some debugging in there. What we can also do with this stuff is that we can execute JavaScript code on top of it. So we have, for example, the package explorer. That's the package explorer down here. We have a console where we can execute JavaScript, and we call main object set. Now you have to look at the left-hand side. There's the package explorer, and if everything is okay, hello J1, and we execute the JavaScript to see that the label changes. We can do even crazier things with it, so we can really move things around at runtime. So let's go to our pod stack here. The live model editor, JavaScript execution, paste stuff in here, and now you should see that the live application model editor is moved at the first position in here. So execute the guy, and you see it moved at the first position in the tab folder. So we can really interact with the model, doing structural changes, removing things, adding things at runtime, and they get reflected immediately to the UI. So all this is possible using the application model. So the future, this is another bug number, and you see the bug numbers get lower and lower and lower. That's the highest voted bugs at Eclipse. It got filed. You should see the date 2002. The bug got filed, and the bug asks for split editor features. So many users that come from VI and all on Emacs know that they can split the editor. And this is the highest voted feature at Eclipse Bugzilla. The problem is that it's estimated that it takes more than a year of man work to fix the problem and get hopefully something in Eclipse to make it work. So 1 year of work. So I didn't have time for 1 year, but I implemented the feature in about a week. And this is only doable using Eclipse 4.x. And now I have split the string class. So I can scroll down here, and you see upside the string class stays. I can switch the layout of it, so moving things next to each other. I can switch between the editors. So And the really nice thing is that the outline view on the right-hand side gets updated. All the time I do a switch. So you see now I switch and then the string gets selected, or I jump to a method. Let's drill down a little bit here so that we see things are moving around. So when I switch to the other one, so the outline view gets updated live. It's really one of the oldest features requests we had at Eclipse implemented in 1 week. So it's really amazing what you can do with this new platform. Yeah? Really? On the same file? I don't know of that, but if it is, then it's good. So the thing is that you should take away from this that we are able to solve problems for you, but what I didn't tell you, I didn't have to change a line of code in Eclipse to implement it, because it's you who can fix the bugs and the problems. This feature that we expected to take us 1 year to implement and get working in FieldX is fixable by you without our interaction. And that was one of our main targets, that it's not us that have to implement all the features. If you want the feature, we have to provide you a platform that you are able to implement the feature without us doing anything. That's one of the major targets that we had when we started working on 4.x. So now I showed you the boring stuff. You can do really amazing things with this new platform, and I have brought with me some cool demonstrations what is possible using the technologies we developed for Eclipse 4 for the Eclipse SDK. And the good thing is, when the Eclipse SDK uses all the stuff, we have many people testing it. It's going to be really, really tested around the world, and it's really a stable platform to build your own applications on it. So what we can do with all the technologies we have, we can implement interesting stuff. So I showed you the Eclipse 4 application platform with the service model and the SWT rendering. This is what the Eclipse SDK is using. The nice thing in Eclipse 4 is I can remove all those SWT bits and replace them, for example, what I did with JavaFX. Oh, we're one too fast. So all I did was I replaced everything that dealt with SWT and replaced it with JavaFX. Naturally, all the views that are written using SWT can't be used on anymore, but if you write an RCP application where you create all your own view parts or UIs, then it doesn't matter that you can't use SWT anymore, but you can use a new modern platform named JavaFX. Let's first look at an E4 RCP application. You can already do some fancy stuff with it, because we provide things like CSS theming. So we have a small demonstration application, and that's a small demo application. You can flip the layout or switch to a background color. So you can already do some nice and fancy UIs using SWT and CSS. But you already see that there are problems. For example, table headers. You can't theme them. The native toolkit doesn't allow you to set a background color on the table header. You can't do anything. For example, another thing is on Windows, a button, you can't set a background color on it. There's no API for it, so we can't do it in the end. So with SWT, you can get to a certain level of UI that looks nice, but well, beyond that, you are forced to do your own drawing or switching over to another platform. So it has its very, very limits with. A really cool thing that I saw, I don't know how it's implemented, but I know they're using Eclipse 4, is they have an E4 RCP application running on the web which uses Vaadin as a rendering technology. So all I did, they ripped out SWT replaced everything with Vaadin widgets in the end and run that thing on the server using Eclipse 4 on the server in a headless mode and doing the rendering through a Vaadin front end in the end. I only have a screenshot of it. That's Eclipse, EclipseRCP, having something similar than a Java editor running on the web in your browser using Vaadin and Eclipse 4. The next thing, that's what I'm working on a lot, is Eclipse 4 on RCP on JavaFX. So we're using the Eclipse 4 platform, and we provide pure JavaFX UIs. We call that a rendering concept in Eclipse 4. It's open sourced. It's provided under EPL, so you can use it for free. And there are the first commercial applications already developed on top of it. This is how such an application looks like. And you get all the features that you know from a rich client application platform. So let me just launch the application. So now we have an Eclipse 4 application running on JavaFX, and you can do all the fancy stuff that you can do with videos and scaling them. You can detach the guy down here. So all the stuff that you're used to from an RCP framework can be done using JavaFX and Eclipse 4. So all those things are already provided. They are stable. They can be used in your commercial applications and provided for free. The problem is that, well, the question was, can you run Eclipse 4, or Eclipse itself on it? The problem is that everything in Eclipse is written against the SWT APIs. So you can't easily get rid of all the SWT stuff. You really would have to implement all and everything you get nowadays from SWT. So getting Eclipse itself running on it is not possible, but I'll show in a minute how you can create your own small IDE using the technologies we have here. So let's go on. So we have Eclipse 4 running with JavaFX instead of SWT. And the next thing is an FX IDE. So I wrote an IDE. It uses OSGI and E4 runtime components. At the moment, it's not using the Eclipse application platform, but I plan to use it in future. It uses and leverages the so-called GDT core. That's the compiler, the incremental compiler you use in Eclipse. It provides you all the search and all the auto-completion functions. And it doesn't require SWT. It doesn't care about SWT. You can even run it in your Maven builds and all the stuff. But you can use it in my IDE, a JavaFX IDE. For editing purpose, and that's the really hard thing to get working in JavaFX, is you don't have a rich editor component. So nothing that you can have something in blue and something in purple. So I had to find a way around it. And what I'm using today is I simply embed a web view. And then in this web view, I have an HTML page with JavaScript that has an editor in it. The editor I'm using is coming from the Orion project at Eclipse. So it's also EPL code. I can simply embed it into my JavaFX web view and make it look like an ordinary editor. In future, hopefully JavaFX will get a rich text control, but for now I'm simply using the web view. And I naturally have a demo with me. So here is my small IDE, and you don't notice that there is really a web view. It really looks like on the right hand side like an ordinary JavaFX widget, but below it it's really a web view, and I have everything working. So I can do system dot out dot println hello J1, save the file, run it. So in the backend, whenever I type, I send all information to the incremental compiler of Eclipse. It compiles my Java class, and in the end, I can run it using Java on my system, and it boots up, and everything works. So that's an amazing feature, and it took me 2 days to implement. Simply using the technologies we developed for Eclipse 4. So it's really amazing what you can do with the new platform that we created here. Let's close this one. Another small application I've written, I call it the FieldX for free desktop. It's written on OSGI and E4 runtime technologies. It runs normally in full screen. It allows to dynamically install, update, and uninstall so-called apps. And it looks like this. And once more, I have a small demonstration about how this thing is working. So I have it running here. Inside my Eclipse, I have a small application I've written. So let's make this guy smaller and make this full screen. So I have here FieldX for free. And here I have a small control or application, and I can drag it from my IDE down here and have a new application installed into my local system, and open it, flies in here and runs the small application. So there are multiple applications. Have a small browser application down here which opens, and when I click here I can browse to a web page and show it on my desktop. So I have a really small system that I can use for a kiosk system or something like that, implementing the technologies once more that are provided or implemented as part of Eclipse 4. Everything under EPL and provided for free. So I think this showcases really how powerful the stuff that we are developing at Eclipse is. So I'm ahead of schedule, but well, it's everything I wanted to show to you. Here are some resources and information about the slides and all the stuff that we're doing. And I'm open for questions. Any questions? Yeah?
Does it support deprecated projects? For Maven support, to properly support Maven, you need deprecated projects. The Maven plugin for Eclipse 3.x was kind of faking that because the Eclipse IDE didn't quite support deprecated projects.
Yeah, so the question was, do we provide for Eclipse 4 something that allows you to better integrate Maven projects, right?
Well, one project containing another project containing another.
No, there is no work being done on the core resource level, so Eclipse 4 has the same resource system than you have in FieldX. There is no change in there. Nobody took the time and implement something. So
Maven requires that because the natural way of building a job with Maven is to have project containing another project containing another project. The Maven plugin for Eclipse is faking it because it
yeah.
doesn't really do that.
Yeah, nobody took the time and spent the money on doing work in this area, so there is no change in there. Everything that's done at Eclipse is driven by what people want, and when they invest time and money on it, then it gets done, and else it doesn't get done. That's all I can say about it. I'm sorry. Yeah?
What do you use to do the dependency injection?
Okay, the question was what we're using to do the dependency injection. We wrote our own dependency injection container. So I'm not part of the decision why we are not using Juice or pBerry or Spring, but I guess that there have been certain features that we wanted to have that haven't been provided by those dependency injection containers, so we implemented our own. It's standard compliant, so it passes the test, the compliance test of the GSR. So
the annotations are all from the JavaFX?
Not all of them. Well, there are two GS. There's JavaX annotation and there's JavaX inject. as a standard, and naturally we have some extensions to it. So the UI event I showed and the app preference, they are not standardized. That's something that we invented for us. So we have a small bundle with all annotations in them, and you have to add that to your project. But they're really only the annotations in there. No other compile time dependencies and stuff.
Maybe one more.
Yeah, sure.
So is any of the work that you've done something that you would want to feedback into other JSRs, where you might maybe participate in the expert group?
Probably, but well, as I said, I'm not part. Well, I'm sure that we have input, and we have been part of it. We have been part of the GSR for JavaFX in Czech. There was Boris Bukowski, who was part of the GSR and fed in his ideas and his things that he needed. Probably we could. Eclipse is part of the GCP, so we could naturally contribute back stuff or information and things that you can use. Sure. Any other questions? Okay, thanks.